Yep.
So, hello and welcome everyone to the annual bootcamp. In this annual bootcamp, we will be learning from the basics to the advanced level of machine learning concepts. So, there are students from various department branches, even other nations. So, in this session, we will try to be more generalized. We won't be focusing on any one of the topic. We will be covering all the topics related to machine learning. I will try to cover these topics. We will be doing some hands-on real projects. You will be taught learning and deployment part. So welcome. So in this first session, we are only going to discuss about the path learning path, how we are going to proceed in the 6 weeks. So just let's start. But before we start, just meet our mentors. The first mentor is Athava Kedkar. Athava, would you like to say something?
Yeah, of course. Well, hello everyone. I guess you have seen me somewhere. I was quite famous in our college WhatsApp groups for some days, I guess. And if I was not, so let's meet again. Well, I am Atharva Khedkar. I am a beta Microsoft Learn student ambassador. And recently, our team was Imagine Cup India champion. And I am from BTech AI fourth semester. So I am very much into AI and machine learning. And like we just want to keep this thing of learning from our mentors and then passing that forward, keep it on going. So we learned some things from our seniors and we want to continue the same. So that's why you're here for. And
Yes,
over
yes,
to you.
absolutely right, Athava. So our senior was very helpful. They mentored us in each and everything, how to learn things, and the most important thing that whatever you learn, just pass on to your colleagues or your juniors. So that's what we learned. So myself, Aditya Bobde, I'm a beta Microsoft Student Ambassador, currently Alpha. So I'm into machine learning and deep learning from the past 2 years. I have already done many of the university nano degree programs, and currently we are trying on the motive of spreading machine learning and deep learning to the people. Okay. So I was also the peer teacher in my college. I was also taking the first year department of my college. So okay, let's start. Yeah, and yes, community bonding is most important. So while you see these lectures, please make sure to drop your LinkedIn IDs or your Twitter IDs in the chat box and connect with each other. Maintain silence, and after the event, please try to retweet whatever you have learned so far. Okay, so we'll be starting. We will be asking you 3 questions. So the first question is, how many people have heard about machine learning till now? That's the first question.
So yeah, does anyone? Okay, so they are raising hands, I guess.
Okay, you can
Well,
type into the chat box. Okay, no issue. Type into the chat box.
uh, Bobde, have you connected any like audio device? Because first it was clear, like it is clearer than before, but when we were having the demo, it was much clearer.
Is it not clear now?
It is, but just there is some kind of disturbance.
Okay, hold on. Let me check.
Yeah. And till that time, so yeah, looks like many people have at least heard about machine learning. So let's get to the second question, that how many of you know machine learning and like have implemented it? So anyone would like to share any idea that they have been working on or any project that they have done in machine learning before? So feel free to type it in the chat box.
Hello, folks. I'm back. I'm audible clear now.
Yeah, much better.
Okay, so I guess so many of you have answered. Okay, so the next question is, how many people know machine learning? The first question was different from the second. What do you know about machine learning?
Okay, so Yash says that he has built a career recommendation system, or I guess
Great.
is working on. Very good.
What will be the, okay, Kanishka, we will be telling you the syllabus. Hold on, just wait. Oh, wait for
Just
2 seconds.
just hold your horses. We would be getting to it. Don't
Yes,
worry.
we have the complete curriculum planned for you.
Yeah.
Haven't done any
Uh,
project, no problem. Harshita,
See,
you
we
will
know
be doing
that
much.
many of you are from CS backgrounds and many of you are interested in machine learning and just want to get a bit hang of it about what this technology is. So this session is for you guys.
I'm not expecting that you know machine learning or you something you are expert in this field. Okay, so great, great, great. So, and the last question here is, how many people have used machine learning? So there are people from different background. They must be using or they have used machine learning. So anyone?
Yeah, we did have some projects before, right? Uh, yeah,
Yes, I have
okay.
seen some. Never used.
And career recommendation system. Well, nice. Okay, so
Yash
yes,
has
there.
used it. Great.
Let's just proceed with the next slide.
Okay, so this will be your syllabus. So kindly explain the syllabus. Can you?
Yeah, okay. So we don't expect you to have any much specialty or any specialization in machine learning because we've got you covered for it. So in the first week, that is this week, you will be getting started about what is machine learning, what is Python. We sent you the registration forms, and many of you did the how much proficient are you in Python? You put the score 1, and we want everyone to be together in it. So that's why this first week would be focusing on them. So the people who had voted more than 3, I guess they won't be enjoying this first week that much. So sorry for that, but these sessions are completely for those people who don't know about Python or machine learning, and they just want to get their careers or like their passion started with it. And the second week, then you will be covering some algorithms, that is the linear regression, logistic regression, and what these algorithms mean would be covered in this session in some time. So stay tuned. And also with these projects, you would be building some project. Also with this concepts, you would be learning with some projects. So we focus on project based learning. So that's why I would be having you to do the house price prediction project and that heart attack possibility project. Moving on to the week 3, you would be learning what KNN is and Git and GitHub. So basically, Git and GitHub is version controlling system, and as many of you won't be having the idea that I am sure of, so that's why that is for you. And with KNN, you would be doing the project of character recognition. So there would be some characters like 1, 2, 3, 4 written in let's say in human symbols, and the machine would try to interrupt it, and it will say that yeah, okay, I see that this thing written here, it is probably the letter 1, it is probably the letter 2. So just like that. And then similarly for week 4, you would be having SVM, OpenCV, and a project on face recognition. Followed by week 5 would be on knife base, and you would be creating a SMS a spam classifier of your own. So just like Gmail does spam classification for mails, you would be creating SMS classifier for yourself on your own. And similarly, proceeding with week 6, you would be having some basic concepts about machine learning cleared, that is PCA and K-means, and you would be building a recommendation system. So as you can see, we have some pretty much packed session for you guys, and we hope that you will enjoy in each and every week. So let's get you started with this first session. And just a quick note that the mail we sent, that we also sent a WhatsApp link. So kindly join it because we would be giving you some instructions there as well. And the main aim of that WhatsApp group is that you interact within yourself and you solve your Q&A there. So let's get started. Back to you, Aditya.
Okay. That was pretty much amazing. I hope so. You like the schedule for the whole week, whole 6 weeks. So yes, we'll be beginning with the session, and you have to pay attention in each and every slide, since at the end of the slides or at the end of the discussion lecture, I'll be asking some of the questions. No need to answer this question correctly, but you have to try that you answer the questions. Okay. So moving forward, we will look into the much broader domain of machine learning. So machine learning comes under a topic called as artificial intelligence. So AI, artificial intelligence is a technique which enables machine to mimic like a robot, mimic like human bodies. So that was the source of motivation in the early 1950s. That how can a machine be able to think like a human being? How can a machine be able to perform things like human being? At that time, a lot of research was going on. So there was something called as perceptrons. These things came first. Okay, so a lot of things came, but during the 1950s, 1960s, these things cool off. And again, the craze came off with the machine learning and deep learning. So machine learning is a kind subset of AI. Now this is a proper step which mimics the human body. Okay, So the problems which aren't solved by machine learning are getting solved by deep learning. So deep learning solves much more complex problems. So deep learning actually depicts your brain cells, how your brain cells are there. In 12th standard, if you have studied what is neuron, what are dendrites. So deep learning represents your typical neuron thing. Okay, so moving on. If you have any doubt in the middle, you can just ping this or throw, or any of the IEEE faculty can reply you. Okay, so moving on to the types of machine learning. So now we will be focusing on the part machine learning. So deep learning, we will be covering it later onwards if you want this series. Okay, so we have three types of machine learning broadly classified as. So first one is called as supervised learning, the second one is unsupervised, and the third one is called as a reinforcement learning. So why this first one is called as the task-driven machine learning or task-driven? So task-driven means that you have to predict a future values. You have given some data, and on the basis of that data, you have some output levels, and you have to predict the future values. Suppose in kind of you have, if you know about stock market, you want to predict the price of the future of the stock. In future, whether the stock will go up or down. If you have purchased a stock for Google of $200 and you want to predict whether it will go to $220 or $180, in that case, you are using supervised learning. Means that is a task driven. You have given a task and you have to predict it. The next type is called as the unsupervised learning. In the case of unsupervised learning, you are given data, a lots of data are given, and in the data you want to classify your members, clusters. You have to form groups. Like if you have watched a comedy series on Netflix, like suppose you have watched Friends or Big Bang Theory. So the next time you open Netflix, you will be shown feed related to comedy series. You must have noticed from the YouTube also. If you watch some comedy or thriller videos on YouTube, the next time you open videos, you see thriller videos or comedy videos. So that's what unsupervised learning do, means it classify the data. And the last type of machine learning comes is reinforcement learning. Reinforcement learning means that you will be learning from your past mistakes, and if a robot makes mistakes, it will punish itself, and if it do something nice or do something that its target achieved, then he will be getting rewarded. So that's the prototype. We will be only seeing the supervised and unsupervised part. We won't be seeing the reinforcement learning.
But
Okay.
the best example of reinforcement learning would be like Indian parents. You know what Indian parents do when we receive good grades? You get, let's say, ice creams. Now there is an I think advertisement of some ice cream. I don't know, but there is some advertisement that the student scores good marks and his parents give him ice cream. And just imagine if the student have failed. Let's suppose that the student is Nobita from Doraemon. So what would happen then? Well, if he had Indian parents, what would actually happen is that he would get a flying chappal on his head. So that is what reinforcement learning is. Basically, they are told that no, you did a mistake, you have to do it again and properly next time. And they fear that and they try to do it proper. So just like that.
Okay, great. That was a great example. So yes, we will be moving forward. So in the machine learning, we have seen these three types: supervised, unsupervised, and the reinforcement learning. Again, when we dive much into deeper into supervised learning, we have two tasks. One is called as a regression, and another one is called as a classification. Now, what does regression does is it tries to predict your continuous values. So what does continuous value represents? Continuous value means your weight, your height, means the values which can be classified into which can be predicted like 154.5 centimeters. Your height can be 165.4, 167. So these are called as a continuous value. For that situation, you use regression. So another type of supervised learning is called as a classifications. Suppose you want to say your friend is asking whether you are coming to the trip. So you have only two choices, either yes or no. So you have only two classes. That's called as a classification. Means
Excuse me.
yes, yes, yes,
Yeah.
Actually, there are lots.
yes.
Actually, you are not clearly audible. There are a lot of interruptions.
So there are interruptions from my side or Athar's side.
It's from your side.
Okay.
I guess that's the birds chirping. That thing is coming too much. Can you just turn off, like, do you have any? Yeah, see that one.
So what do I, okay? Rasika is saying you are audible, you are clear. So I guess so with the words noise.
Just do a thing that like just keep your mic closer to you. There is just that background noise of that bird chirping, so that is just
Okay, okay. The birds thing, okay.
yeah.
Sorry for the birds. I have near about 40 love birds in my home. I have African parrots. So I have a bird of homes. I love birds. So I can't do anything. So I will hold my mic closer to that. Okay, so now we have seen the supervised learning, regression and classification. In regression, you use continuous values, and in the classification you use discrete value. Discrete value means either yes or no. Means you got it whether or not you want to go, either the answer will be either yes or no. But in the case of regression, your answer can be very strong since it is a continuous value. So if someone asks you what is your weight, so some person might say that my weight is 156.7 56 kgs. Some other might say 58 kgs. Some other might say 75.4 kgs. So that was supervised learning. In supervised learning, a regression can be used for weather forecasting, whether it will be sunny, rainy, estimating life expectancy, growth, population prediction. These are the regression supervised learning tasks. So when you go on to the classification, you can do cancer detection, customer retention, image classification, and fraud, credit card fraud detection. So credit card fraud detection is a typical example of classification that is usually mostly in the real world case scenarios. Okay, so moving on to the unsupervised learning. Unsupervised learning has also the two subtopics. One is called as the clustering, and one is called as the damage reduction. In clustering, you have the recommendation system. So you must have Netflix, Amazon Prime, and YouTube. So all these companies use recommendation systems. This is the most widely in the case of unsupervised learning. That is recommendation system. If you watch a series, it will recommend the similar type of content to you. It is can also be used for target marketing, customer segmentation. Suppose you have a website, you sell lots of different products. So for a person who handles that website, it will be difficult for me to know whether the person is paying for my shopping shoes or clothes or toys. So it can help us to segregate the data. So that's what clustering is used. And in the case of damage reduction, it is generally used for your data calculation. You have too much of data, and to reduce the data, you use damage reduction. And the last is reinforcement learning. You have must heard about Google's AlphaGo. Has anyone heard about Google's AlphaGo or watched that movie? Yes. Anyone in the chat? Has anyone heard of Google's AlphaGo?
Yeah, can anyone just type it in the chat? Yeah, Bhavna says yes. So at least they know what AlphaGo is. And for people who don't know, just now Daryl said, so Aditya, just tell them what it is.
So AlphaGo was a system developed. So it was able to beat human world championship. The world champion, he was able to beat him. It was developed by DeepMind Technologies. Now it is acquired by Google. So that powerful reinforcement learning is, suppose in the case of chess, you have some 18 moves or 20 moves, but in the case of reinforcement learning, it is able to think about 10 to the power 90 moves at the same time. Okay, that powerful reinforcement learning is a lot of calculations is involved in reinforcement learning. So okay, we will move forward. So now what's machine learning? Okay, now that's what we want to
Okay, before we move into this, I just want everyone to take a question that can anyone just Google it that when was the term machine learning coined? Yeah, okay, yeah, Sana knows about Deep Blue too.
Great, great.
Yeah, I would be just like asking you to just Google search or just see that when was the term machine learning introduced, and when anyone answers that in the chat box, then like I'll proceed further. So yeah, okay, well, Keshan says it. Well, it's not 1952, it's 1959. That's right. Okay, so can you just imagine that this machine learning term, this machine learning technology, we have it from 1959. So why is it a buzzword right now? Why is there like, oh my God, machine learning, oh my God, such a new technology? Why is it now being implemented in the years 2020, 2021 like that? When this technology was introduced back in 1959. So does anyone wonder that? Well, the reason for it is because that time we knew what machine learning was, but we didn't have that resources. We didn't have that computational power. Yeah, that's right, Keshan. Because now we have that computational power, and just that computational power, that's not enough. But with the computational power, now we have the data produced with us. So we are producing more data than ever right now in this time. So that's why we have the data, we have the computational power, and we are fighting it. Jack says just like Iron Man father. Well, that's correct. So yeah, let's proceed, Aditya.
Okay, so you have much got a knowledge about why machine learning is such a hype in the late 20s. So that's the reason that you have a lot of data. Previously, the data wasn't available. So you won't be knowing, but your each and every data is recorded by Google. If you are using any smartwatch, any smartphone, Google Assistant has absolutely each and every answers like Siri. So your data is being recorded each and every time, and that's used for your prediction. So that's the meaning that you are using data. Now the data is used for training. And what you have to do, you have to give the answers based on that. Means you have to predict your answers for the question. Okay. So before machine learning or before artificial intelligence, there was traditional programming. We were inputting the set of rules and the data, and the traditional programming will do some computation and it will give us the answer. Okay. But in the case of machine learning, what we'll do is we'll give them the answers, which are the required labels. We'll give them the data. We have already tons of data, and we'll give them the answers related to that. And on the basis of that, the model will try to figure out the rules differently. We won't be having to update each and every rule. So we'll take a typical use case of that. Okay, so if I'm marking an email as spam, what things would you see if the email is spam or not? So what things is typically there in the spam emails? Some highlights, some keywords. Would you look when you see a spam email?
Yeah, can anyone share it? Because I would be marking it as spam when I will see that you have won $1,000. Like, yeah,
Okay,
you
and
are
Nakul says
definitely
advertise. Yes, and I want more and more participants in the chat. Let it be wrong.
say anything is spam. Of course, if anyone says that I would give you $1,000 right now and something, then you know it's like bull, right?
Yes, someone says you have won a 1 million lottery, or
Uh,
you are amazing. Your
what?
credit score is increased $4,000. Okay, sort of warning mail you are giving now, but if you don't have warning email, so what would you think? What are the buzzwords or what are the keywords on the basis of that you will be marking the email as spam or not spam? Okay, Ritik is great. 1 lakh related, absolutely offering money for no reason and asking details. Yes, great. Yeah, Jack is great.
Yeah, see, someone
So,
was giving Aditya Rao some infinity stones. Yeah, on black market, I guess. So of course this is the fake thing. And what in traditional programming you would do is you would write rules for it. So if anyone says that you are getting infinity stones, you are getting some new technology, and yeah, Jay says you can win iPhone. So yeah, if anyone says like that, then probably you would be writing an if else statement for it. But it was previous machine learning. So now what happens is that you just give them the data. Okay, so these are the all the emails that are spam because we know they are spam. We have read it and we are just giving you machine. See, these are the spam emails. I am giving you the data. I am giving you the answer that this is spam. Find it out by yourself that how are they spam. So just like that.
okay, the spammers will be also be getting clever day by day, so they will be noticing that they are sending the message that you have won an iPhone, so they will be changing that. Suppose from iPhone they will be moving on to the now you have one scratch this coupon and you will be winning $1,000. So they will also be getting advanced. But for a traditional programming, if you are using traditional programming techniques, then you will be needing to updating each and every buzzword that they are changing. But in the case of machine learning, the system will automatically try to figure out that scratch this coupon or you're winning a lottery. So that's the typical use case of machine learning. I guess so you know the difference between the someone if asked about what is traditional programming and what is machine learning. Okay. So yes, this was our traditional approach. You have to study the problems. You have to write some rules. Suppose in the case of spam mail classification, spam means the mail is not relevant to you, means you don't want that mail, it is something fraud kind of, and ham mail means that it is important to you. Just understand the difference between spam and ham. So okay, so you write the rules for your spam mails, you will evaluate it, but if it is successful you will launch, else you will analyze the error and do go on looping onto the system. Okay, so this was your traditional approach. So we'll now be moving on to the machine learning approach. What our machine learning will do? You have a problem like classifying a mail as spam or not. So you have your different algorithms. Okay, and you will be providing you the some of the data, lots of data which you have collected, and the data will be fed into the machine learning algorithm. It will try to figure out some patterns. Okay, so suppose it contains your lottery, surprise, gift, iPhone. So on the basis of that, it will try to figure out some pattern and it will evaluate. Okay, so now that's a quicker approach and automatically learns the machine over a period of time. So you would always prefer machine learning approach or traditional approach. Okay, so you have your training data, means data you have collected. You will feed into the algorithm, and algorithm will do some competitions and make a model, and the model will make an output. Now the part that is this one. Okay, this typical part, ignore the test data. Now this typical part is known as your training model. You are training the model T. Okay, so once you are done with the training, what you will do is you won't be launching the model into production. So if you have 100% data set, means you have 100 samples of your data, whether it is spam or not spam, you will only feed 80% of the data. 80% means you will feed only 80% of the data to the training, and you will keep rest 20 aside that the model won't be seeing. And on the basis of that, you will try to predict whether your model is performing on the unseen data or not. This is the most important step. If you are using all your data for training, then it is not a useful model. It will generally try to underfit or overfit. But always remember that you have to segregate your data in the ratio 80-20 or 70-30. Okay, so next we'll see the learning approach. So I guess so you are all from different backgrounds. I won't be generalizing that you know any language or specific. First year students are there, lots of other students are there. So we'll start with the basic approach. So to you learn machine learning, first you have to learn any programming language in R or Python. Any means not C, C++. Okay, you can do in that, I don't know. But you have to learn either Python or R. Okay, so you have two languages. I would rather go with Python since all the libraries are very handy in Python. So okay, that you have to learn the language. Second, you have to learn some pre-processing techniques like Excel and Python libraries. And the third step is basic libraries of Python. Now these are the most important things. Okay, the first one is the NumPy. So I wish you guys take a copy and pen and write some of the concepts which I'm teaching. That will be helpful for you in the later. It's always great to have a copy and pen. Whenever I'm learning a new topic or whenever I attend a seminar, I generally take copy and pens to write down the notes, because what you hear you can forget in an hour or two. So just for the sake of, you just take a copy and pen and write down these things. So you have to learn a language, Python or R. You have to learn some basic libraries such as NumPy, it is used for mathematical computation, Pandas, Matplotlib, and scikit-learn. That would be more than sufficient for your machine learning. Then you have to refer some books. I will be sharing some books or online content, YouTube videos, and try on real world projects. So for trying out real world projects, you have a site named kaggle.com where you have tons of data set to go and experiment with. And once it is done, now this is a complete time frame of your machine learning. And once you are done with the machine learning, you have time to deep into the deep learning topics. So that's the whole timeline of machine learning.
Aditya, could you go back to the last slide? I guess Saurabh was not able to catch the glimpse of it.
Okay, so last slide. This one?
Saurabh, is it this one? Can you please reply? Yeah, he was not able to get it.
Okay. I will explain it once again. So in the case of machine learning, suppose you will be feeding the data and data points. Suppose you have 100 data points. So you won't be feeding your 100 data points direct into the machine. So what you will be doing is you will be splitting the data into the parts, like 80% part or 70% for the training, and the rest remaining 20 or 30% for the testing. Because if you use your data for the training, the model will be seeing the data. Like it is the case in the scenario, if you are learning whole from the book, if you are studying for the semester and you were learning continuously from that book that teacher has showed you, but in the exam the teacher gives you question outside from the book. In that case, you won't be able to solve the question because you have learned the book so thoroughly that you don't know what's outside the book. So that's the main aim, that you should be reading along with the book some other contents. So you will be segregating 20% of your data for testing, and the rest 80% will be used for training your system. Okay, so this concept will become late on in the later class. I will just explain for you.
You will see this in practice as well, and it's not like it is, you can't say it's important, but it is the best practice you do, because just imagine that you have seen all the data and you don't have any else information left for you to evaluate model. So what you'll do is, like, you will be training your model on some data, it's okay, but what, like, it's not always possible that the model is able to see all the data. Let's, for example, let's say that the model is learning in English. What if someone from like other language, let's say there is let's say Japanese, someone is doing some mails in Japanese, so what about that? And let's say, like, even in English there are lots of syllables, there are lots of words, so how is it possible that you would be able to cover each and every word in it and the model would be able to get the glimpse of it? So that's why this thing is preferred, so that you can evaluate your models on it. And don't worry, that this would be coming later on, then you would be knowing why exactly this thing is happening. So let's proceed.
Okay, so now we have understand the learning approach, so we'll moving forward. So yes, some advisors were asking that is Python the best language to learn machine learning? Yes, I would recommend that you should go with Python. But if you want some other language, you are not comfortable with Python, you can go with R. That's your choice. Either you want to learn Python or R, but I would suggest you should go with Python, since most of the libraries are compatible. Yes, Atul, you can add it.
As you brought this thing up, so let's, like, give you a general case scenario. So, like, the best languages for to do machine learning are considered both Python and R. Python a bit more because, like, the people are going to get a hang of it pretty much more, and it's like very easy and like completely just like reading English. So that's why people are like loving Python so much. But it's just about your preference. Like, email is a service, so some people prefer Outlook, some prefer Gmail. So it's like just about that. What about Julia? Yeah, actually, people in industry use Julia as well, but the, like, what do we say? The people using it, the total number of people and developers using Julia, it's a bit less as compared to Python and R. So highest is Python, then R, and then all the other languages like Julia, Scala, even C++ and JavaScript are becoming popular, but Python would always be first, I guess so.
Yes, yes, yes. Even if you try to do deep learning after machine learning, of course you will try to do deep learning. But in the case of deep learning, you will be implementing different libraries, PyTorch, TensorFlow, Keras. These all libraries are mostly used with Python, much more preferably. That's why I would suggest you should go Python with the first choice or with the second choice. That's up to you, what language you want to learn. Okay, so the now next question is, what comes to your mind when I say about machine learning? What is machine learning? I want some answers in the chat box. I'm expecting some answers. Let it be random. So, do you think it is a deadly Terminator robot, or what? What's machine learning?
Yeah, so was anyone able to get the hang of it, that what machine is, like, machine learning is? I'm sorry. Yeah.
Okay, Nakul is saying intelligent machine. Yes, you could try random guesses.
As humans does. Yeah, training machines as human does. Exactly. It is artificial intelligence. Well, no, Chow. Actually, machine learning is a subset of artificial intelligence. So a bit correct. Making a machine or program learn based on model. Yeah, that's exactly correct, Edward. That's exactly what machine learning is. Algorithms improving on its
Okay,
own.
so when I heard about machine learning from my seniors, I thought it was a deadly terminator. So yes, it depends on the different perspectives of different people. So yes, you know, great. So okay, so we'll be focusing the topic which we have seen earlier, that is supervised machine learning. So now what does supervised machine learning do? It has the data inputs and output levels. Okay, the output can be continuous. As I told you, the continuous values means your height, your weight, that is continuous values, or discrete values. Discrete values means your yes or no, whether you will buy it or no. Okay, so that is a discrete values. The algorithm tries to find the pattern between the input and the output phase. So if you want to predict the salary of a person, so what features you will be requiring means what features generally you will be requiring, that the person has some years of experience, the person has some education, PhDs, masters. On the basis of the person's education and the person's years of experience, you would try to predict the person's salary. So now this is a typical use case of machine learning. Once the pattern is done, it can be used for predicting future results. Okay, so means you have some labeled data given, you want to predict your future outcomes of the data. Okay, so that was supervised machine learning. We move on to some examples. Before moving on to the examples, there are mainly the algorithms, supervised algorithm which we will be learning in this session are linear regression, logistic regression, decision tree, uh, random forest, support vector machines, naive Bayes, KNN, and k-means. Okay, so I won't be going into the much details since this is just an introduction.
Yeah, this is just the list of the supervised algorithms, and don't worry that you would be learning each of these algorithms in the upcoming sessions.
Yes, yes, yes. These are the just basic overview. Okay, so what does a supervised algorithm tries to do is, you have your labeled data, means there this is a rat, this is a dog, and this is a lion. You are already given labels, means you already have some answers. You train the model and the model will do some prediction and will correctly try to classify that this is a lion and this is a dog. Okay, so that's the goal of supervised, that you have already answers. Okay, so the typical use case we have already seen is the spam mail detection. You will be inputting the previous mails, previous lots of tons of data, and what is your output? What do you want to predict? Whether the mail is spam or ham, whether the mail I want to get is relevant or irrelevant. In this case, you will be using supervised machine learning, and this is a typical classification problem. Now, can anyone tell me why spam mail detection is a classification problem? I just drew the difference between the classification and regulation. Yes, any random guesses, you let it be wrong. Why it is a classification problem? Spam mail detection.
Don't worry if it's wrong, but like just because it would be either spam or not. Exactly. So it will be a class. It would be something that could be counted. So like kind of an example, very limited. That could be one. Not classified, but classified would be something secret. No, so it's like not something secret. Has two classes of output. Yeah, exactly.
Yes,
And
yes,
the
yes. Great, great.
so yeah, so just continuing to this, it has two classes. So that's why this is binary classification. Binary two stands for two. So two means binary. So binary classification. If you
Great.
have more than two classes, 10 and all, so it would be like
Multi-class.
multiple classification. Yeah, multi-class classification problem.
Okay, so this was a typical use case of spam mail detection. And you must have seen this meme a lot. Stonks. Okay, so now what is this man is trying to figure out? So he has purchased some shares of Apple from the New York Stock Exchange, and he want to predict that whether the Apple shares are going to fall or either it is going to rise. Okay, so the input is your previous stock data from the 10 or 15 years of Apple stock data, and the output is he's trying to predict out the stock values of Apple. Okay, and it is a typical use case of regression. Now, why it is called as regression? Either firstly you have seen the classification. Now, why is this regression? Stock price prediction is why it is called as a regression problem.
Just think that can this data could be converted into classes? It could be by giving ranges, but not giving ranges, but exact points. Can it be converted into classes? Yeah, exactly. Value may be a range of numbers, and like there would be a lot of numbers, right?
Okay, there might be numbers in the fraction 24.8899. The stock may be ranging from $200.55 or $300, $302. So it is a continuous output. Yes, correctly, absolutely, Tusha. It is a continuous output. That's why it's called as a regression problem. Okay, so now I hope so you are able to differentiate between regression and classification. The regression, simply note the regression means continuous values and classification means discrete values. Yes or no? Okay, have a copy and pen. Okay, so the robot is trying to figure out what the teacher is telling him. So the teacher shows that it is an apple. The robot says no, it's a banana. But the teacher correctly says that the robot says it is an apple, and the teacher says yes. Okay, so that's the typically what scenario of supervised learning.
See, the best example to get a hang of it is consider machine learning as a small kid. Okay, and let's relate with this kid. So let's suppose there is a kid. The kid could be your own brother or sister. It could be your brother's brother or sister. Okay, it could be your niece. It could be your nephew. भाई का बेटा बहन का बेटा doesn't matter. Okay, also बेटी भी हो सकती है. So just take an example that there is a kid and you want to teach them something. So what do you do is you put on table around hundreds of apples, hundreds of oranges, and you show them, see this is called apple, this is called orange, and they try to figure it out on their own that what is difference between these things and what could be an apple and what could be an orange. So they might be going after color, they might be going after shape, it's up to them. We can't actually see that what they are trying to do, but basically it's just like that. And this would be supervised learning. Why? Because you're telling the kid, ki, yeah, this thing is called as apple, and yeah, this thing is called as orange. So just like that, this is an example of supervised learning.
Okay, great. Absolutely. So I hope so you know what Atharva has explained with a very simple example. This is the best example I have ever seen. Okay, so moving on to the next, we have unsupervised machine learning. So we have seen supervised machine learning. Now we will move on to the unsupervised learning. In the unsupervised machine learning, you have given data, but you won't be having your output. There won't be having labels. So no outputs are associated in the case of unsupervised machine learning. There is no one. Means suppose you are learning some subject, you might have a mentor, and the mentor is trying. If you are doing something wrong, the mentor will be telling that you are learning something different. Be on the track. Be on the right track. Okay, so that was supervised learning. But in the case of unsupervised learning, there is no mentor, there is no teacher to guide you. You will be learning by your own. So now that was unsupervised machine learning. So it tries to use the rule that people who bought X will also bought Y. Means if you have seen some, I guess most of you have seen the Friends series on Netflix or any comedy series. So if you watch Friends, Netflix will try to recommend that you will be also liking Brooklyn Nine-Nine or some comedy series, Two Broke Girls, Two Broke Men, Two and a Half Men. So means it will try to predict that people who also watch X have been also watching Y. Okay. So X is your friend series, Y is your Brooklyn Nine-Nine series. So that's the relation in unsupervised learning. So the unsupervised one learning, which will be seeing algorithms will be K-means, hierarchical clustering, anomaly detection, principal component analysis, and independent component analysis. Again, I won't be going in much detail since this is a first lecture. We'll be seeing some of the examples. So you have your input data, but you notice that you won't have labels here. So you don't have labels whether this is a watermelon or this is an apple. So the model tries to classify now this is an apple and this is an watermelon by its own. So where is the use case of this? Suppose you have your own website. On your own website, you are selling products like small kid toys, small kid clothes, the PlayStation 5 station, small kid books, story books. But you aren't sure which type of customers are coming to your site more. In that case, you will be using unsupervised learning. It will try to figure out now these patterns. This type of people are buying small kid toys. This type of people are buying small kid storytelling books. So that's used for market segmentation, trying to figure out clusters. Okay, so that's the main motive of unsupervised learning. Now robot is trying to learn by himself without the data. So he is getting very confused. Now this is an apple or this is an banana. Okay, so finally he's tried to classify it. Now this is an apple and this is a banana by itself. Okay, but it was very frustrated at the first moment. Okay, so that was unsupervised learning.
Yeah,
Uh,
let's get the kid back again. Okay. So let's bring your niece, your nephew, your bhai ka behan ka beta back again. So now they are trying to figure out what are apples, what are bananas. But in this scenario, you're not telling them exclusively that what is called what. So you're not telling them that, yeah, these are bananas and these are apples. You're just leaving them with the table and you're just telling them ki, separate these two things out. So he would be just trying to separate these out by seeing different types of features all by himself or all by herself and just separating it out. The difference would be that you won't be exclusively telling them कि yeah, this thing is called as apple, this thing is called as banana. So the basic difference between supervised and unsupervised learning would be in supervised, you tell them, okay, so this is the label, this is the email, and this is a spam email. This is not a spam email, this is an internship offer, like that. But in unsupervised learning, you won't be telling them exclusively that what things you have, you would be just giving them data and you would be telling that, yeah, like cluster it out, just differentiate somehow. And mic is off.
guys, please keep your mics off. If you are any doubt, just type into the chat box.
I muted everyone. So yeah, so like the previous example that Aditya showed, could you just go to the previous slide, Aditya? Yeah, so this man is Jeff Bezos. Okay. And the in between this is his Amazon. And what Amazon is trying to do is it's trying to separate out the people that, yeah, these people bought, let's say these people bought a table. So let's show them some fans. These people bought a mouse. So let's show them some keyboards, the recommended items that you see on Amazon. So that's the example of unsupervised learning, because you're not telling them exclusively that what to do or giving them labels, but you are just giving them the data and you just want them to be figure out and find some things in common. Yeah, exactly. I'm sorry if I'm pronouncing your name wrong. Manasvi, I guess. Yeah, Manasvi. So yeah, you are exactly correct. So machine is finding common characteristics to form groups on its own. Exactly. Yeah, that's exactly what Google and Facebook do. And even Netflix does. Once you finish a series, they give you another one. Just see this one. So it's like that.
That's how they keep engaging you, and you have to pay subscription. Each and every company you are seeing is using machine learning, whether it be Google, Microsoft, Facebook, Amazon, Flipkart. Each and every eBay company is using machine learning to figure out the customers on each and everything.
And if
Okay.
you're like very much interested, you can just Google it out that using machine learning, how much they have increased their sales over this past decade. So actually, it's been a very beneficial factor for them to use machine learning and giving them user data. So that's the basic reason they steal your data. That's why Sundar Pichai is mostly in the courtroom telling that no, we didn't steal the data, because they are trying to figure out some patterns and they are just trying to make their services better.
Yes, and they sell the data for a lot of money.
Yeah,
Suppose there is a
that's
small company. Suppose there is a small company X which is trying to sell the products, but it is new to the market. It won't be having so much of data. But the companies like Google, Apple, Microsoft, Facebook, they have tons of data available. So they pay a heavy amount for to these companies for Google that sell me this customers' data. So we will be able to generate our sales much more faster. Okay, that's why the data is sold. Okay, so now the last topic is reinforcement learning. So the learning agent, there is a learning agent. It tries to observe the environment and performs action. And in return, he gets rewards or he gets some pain kind of thing. So it learns by itself. It doesn't have anything like you. It doesn't have labels or doesn't have some data. It observes the environment and it tries to learn by its own. DeepMind's AlphaGo is the best example of reinforcement learning. So now seeing the example by this. Suppose this is a robot, namely agent. Okay, so what does the agent do? So in one end there is water flowing from the tap, and another thing is fire. So first thing he will do is he will observe, and second step he will select an action using his policies rules. Okay, so he will randomly approach. So if he have approaching fire, so he will be getting. Suppose he's being deducted minus 50 points. Suppose he will be 100 points are there, so 50 points will be deducted because he touched the wrong thing. Next time he will learn that there is a fire in the right direction. I would be avoiding it, and I will be going on to the tap section. So when he goes to the tap section, he is being rewarded with plus 50 points. That's how he learns. Atharva, okay, could you give the example of the child again?
Yeah. Okay. So again, now here is a child and reinforcement learning. So this would be the exact example of what I told you about the ice cream. Okay. A kid scores good, he gets reward. A kid doesn't score good, he gets beating. So exactly the thing happens in reinforcement learning. So I guess you are just getting the hang of what is the difference between all three types of machine learning. Okay, there is supervised, there is unsupervised, and there is reinforcement. And these were the differences.
So this is how a robot plays. Now the input is others player information, the environment he is watching, how others player is playing. On the basis of that, he will take some action. So this was the example of reinforcement learning. Now let's took some examples of what does machine learning or what does the field of AI does. I'm not specifically talking about machine learning. What does the field of AI does? So there are numerous examples which you will be seeing in the lot of world. So have you anyone used Google News or news section in the Google? I want some replies into the chat box.
Yeah, any reply about the news you see in Google? It could be
Okay.
like now they have added it in the home screen, I guess, because I see in the home screen when I swipe left. But even if it's not there, then the Google app itself you can see at the bottom side.
Yes, yes. So what does Google News does is it tries to classify the data. Means you have economics data, you have entertainment data, you have sports related data, you have your international news, you have national news. So what all these things are called as, they are doing clustering. So each and every minute tons of data is added to internet. So what Google tries to do is it tries to cluster some data, and on the basis of that you are seeing the news related to entertainment or your international news, sports news, education news. First example of that was clustering your data in Google News or any news. The second one is widely used in the field of medical health, that is detecting your tumors in the brain. Suppose there is a tumor, so machine is much more efficient than doctor to predict whether there is a tumor or not. Okay, so this was the second use case. The third use case is you have been seeing some Telegram. Some of you might be using Telegram or some other apps. Whether you post some offensive comment or offensive word, it tries to delete by its own. Now that's a bot which is developed and trained on specific offensive words. That if you see some of the words, you have to delete by its own. So that is automatically flagging offensive comments in the discussion forums. The next thing is in the Google News itself, you have a very long news, but you are lazy. So Google gives you a short headline. So the headline is also generated automatically. That is summarizing long documents automatically. It is also the use case detecting credit card fraud detection, as I already told you. So, and the most important, the most in-demand skill is making bot. So if you visit each and every website nowadays, so there is people, means the people are getting replaced by bots. So you have a bot, whether it's your electricity bill app or you Amazon, Facebook or anything. So you have your bot, you ask the bot, hi, the bot replies with some of the questions, you select one of these answer questions and the bot replies. So that's the main use case of natural language processing, which is widely used the bot.
Okay, Darshan gave an example of automatic car parking. So let's elaborate it. Like let's stick to this example and try to get a hang of it. So let's take an example of, let's say, Tesla cars. Okay, so Tesla are automatic cars. The other one is being developed by Google. I forgot its name, but yeah, there is some partnership with Google going on. Waymo, yeah, Waymo it was. So let's say Tesla cars or Waymo. So they're automatic driving system. So what happens is that in these automating systems, they would be fed with the information of people, the cars, like whatever they can catch in the environment. So what it initially would have happened in them would be they would be shown a tons of pictures of different things, and they would be told, yeah, this is how humans look like, this is how cars look like, this is how like any other, let's say, pole or the signal looks like, and it would be a part of supervised learning. And then how to drive. So what happened is that like during training any automatic car, what they did was they drove that car for like thousands and 2000s of kilometer. Some human, excellent human drivers drove those cars for like 1000 and 10,000 kilometers, and they analyzed it by themselves, like, okay, this is how I should drive, this is how I should perform when I see the signal is red, when the signal is green. So that data and getting the hang of that data, that is called as reinforcement learning.
So I hope so you have got the broader way of how reinforcement learning works in self-driving cars. Okay, yes. Okay. So now the next topic is there. Every coin has two sides. So if there are lots of these many advantages of machine learning, so there will be some of the disadvantages also. I would be seeing disadvantages. These are some of the major drawbacks that you want to focus while building your machine learning. The first one is your insufficient training data. So as I already discussed, on what basis your machine learning, why machine learning came into play? That because of your data, your tons of data. But if you don't have enough data to train, then it won't be useful. So for a kid to learn whether it is an apple, you just have to point out this is an apple. But for the machine learning, it's not the same case. It requires tons of data to learn from and how we need to figure out the data. So that was your first point, that you have insufficient training data. You don't have much data. Okay. The second one is called as the poor quality data. Even if your training data is full of errors, outliers or noise, it will make it harder for the system to determine the patterns. Okay, so as the algorithm tries to find out the patterns by itself, but if it has lots of error or noise, it will be very difficult for the models to find out the patterns. Now for this process called as a data cleaning, and this is the irritating part for me. It is the irritating part because in the data set, the 70 to 60% of your time goes into data cleaning. Applying algorithm, making the production are the very less things, but cleaning your data is the most important things. So the second drawback is done. The third drawback is irrelevant features. There is a saying called as garbage in, garbage out. Your system will only be capable of learning if your training data has relevant features. Means if you are trying to predict the house based prediction, but you have the data that whether there was a ghost hunting in the house, so that's a completely irrelevant features. So no one is taking into that consideration. But the features that would be taken consideration into is the square feet of the house, the number of bedrooms, the number of gardens, parks around the house. So that you should have relevant features. Last but not the least is called as the overfitting and underfitting concept. So in many interview questions, you have this term called as overfitting. Today only itself, we have a machine learning viva, and this question is asked many a times: what is underfitting and what is overfitting? So this is the most important. So I will explain it in the most easiest way. Suppose you are visiting a foreign country, and the taxi driver rips you off. So you might be tempted to say that all the taxi drivers in that country are thieves. Okay, but is that the case? So only one has ripped you off, but you are generalizing that all the taxi drivers in New York City are thieves. So unfortunately, machine can fall in. So overgeneralizing is a tendency of human. हमारी टेंडेंसी है कि एक चीज को मतलब बोल देना कि अगर ये चोर है तो सभी के सभी चोर है. So that's the not so same thing can happen with the machine. If you overgeneralize your model, the machine learning can fall into the same trap and it will overgeneralize the data. Means it would say that each and every taxi driver in New York is a thief. Okay. The opposite is the case of underfitting. You don't have enough data, so the model becomes too simple. So what you can try to imagining is that in the case of overfitting, so you want to kill a fly. So this is your fly. Pardon me for my drawing. Okay, so this is the fly which is flying. I don't remember how this fly is. Okay, so this fly is irritating you so much. So what's the easiest way? You have an electric bat, or you can kill it with something else. You have a herbal spray to kill this small fly. But what you are doing, you are taking out the gun to shoot the fly. So now what does it says that you are killing a fly with a very, so killing a fly with a gun is not the solution. Okay, so you are using an extremely hard model for your killing the fly. So that's not relevant. So that is or underfitting your data. In the opposite case, if you are trying to deal, if you are trying to kill your soldiers, means if there is a war fight at the national levels and you are trying to kill the enemies with a rod or something, and the enemies have guns and lots of armory, then you will be easily killed. Now that's called as overfitting your data. So that's the difference between underfitting and overfitting. We'll be diving much into the underfitting and overfitting in the latest model, but that's it. So if you have any doubts, please try to put it into the chat box. We will try to answer it. And later, after 2 to 3 minutes, I will be asking some of the questions. So you have to answer these questions. Yes, can you share the recording with us? Athava, is the recording available? Hello, Athava?
Okay, I was talking in mute. So yeah, exactly. We would be sharing the meeting. Actually, like we are recording the session, and this session would be then uploaded to YouTube, and you can watch it anytime on YouTube.
So what's about the WhatsApp group? Will you...
As well, PPT would be shared with you guys, so don't worry. Okay, I had something to say and I forgot.
No problem. We have some more time. Okay, so any more doubts, or shall I proceed with asking you some questions?
Speaking of it, they are always been recording. All the videos are on point. Yeah, exactly, Keshan. I agree with you.
What is he saying, Keshav?
He's saying the YouTube recommendation system is excellent. I guess.
Yes,
like,
yes.
Usually, how would us as designers overcome overfitting if we don't have enough data in the first place?
Okay, so if you don't have enough data, that's called as underfitting. Means you don't have enough data. But there are various statistical methods to find out whether your model is overfitting or underfitting. So you have different evaluation metrics to find out whether your model is overfitted or underfitted. Then wait for it. We will be taking live examples of this. Okay, so how does to overcome overfitting and underfitting? Okay, any more doubts?
Yeah, and also like tomorrow, what we would be doing is we would be getting started with Python, and we would be seeing some libraries and some statistics you want to know before proceeding with machine learning. And from the next weeks, we would be directly jumping on those algorithms which you saw in this PPT.
Yes, Rasika, tomorrow the same time.
Actually, we had some clashes with time, yeah.
So we are there are more than 150 to 100 students from Malaysia which are joining.
Shout out to them.
Shout out to the students from Malaysia. We are very pleased that you are a part of our ML bootcamp. It is an absolute pleasure for us to teach students like you from the outside nation. Yes, that's great. Is search engine optimization a part of machine learning? To some extent, it is a part of machine learning, Manasvi. So pandas, numpy, matplotlib. What are you trying to say, Harsal? I'm not getting it. These are the libraries you want to study.
Someone asked for, I think, WhatsApp link, so here it is.
Okay, just send me the WhatsApp link.
As NumPy, Matplot. Yeah, well, these are the libraries. Is there a question with it, Harshal?
That's what I asked.
Is search engine optimization a part of machine learning? I don't think so, Manasve. It's a part of machine learning. It's completely different field, but I think it would be having influence of machine learning as well. And yeah, tomorrow's session is hands-on.
Okay, so tomorrow we will be learning some concepts of linear algebra, some Python and the basic libraries which we'll be going to use. So if you want some brush up concept, just go on to the YouTube. And if you know 3 Blue 1 Brown, he's a very famous YouTuber. So just try to watch his linear algebra videos. Don't watch it completely. Just overview is enough, more than enough. You won't be requiring much of the details, but just have overview. So that's the best channel for you.
Could you
3
just
Blue
type
1.
the name of the
Okay, 3 Blue 1 Brown. That's the channel name.
write it on the chat.
Okay, hold on. So he is an, just mark this name, 3 Blue 1 Brown. He is an excellent in the case of you want to understand anything, matrices, vectors, anything. Is it good practice to use classification for recommendation system? Yes, it's a good practice. Any more doubts? Which platform we will be using for coding? Okay, so it is totally up to you which platform you want to use. So for coding, you can use Google Colabs. It's absolutely free. For coding, you don't have to install dependencies. You don't have to install libraries. So you can go with Google Colab, or else you can have your personal editor like VS Code, Jupyter, Anaconda environment, anything. That's up to you. Completely up to you. Harshal, I already gave us the link about 3 Blue and 1 Brown.
Okay, so we have a form in the chat. Could everyone please like fill the form so we know that which time suits everyone the best? And also the times are in IST. So the Malaysian time is like 2 hours and 30 minutes forward to us. So just take a look at it. Please, everyone, just fill the form which was just shared by Atharva Devlalikar. How many sessions per week? One session on Saturday and one on Sunday. So exactly 2 sessions per week, and it is on weekend so that it doesn't have anything to do with what you do on weekdays. It doesn't
Yes,
with your work, and there won't be any homework, I guess. So
yes. Means homework means we will give you some of the topics to research by its own, but it's not compulsion. But it's a better practice to see what you have learned.
this form that Atharva sent in the chat, just
I know
here
guys,
it is.
one of the slides we saw recommendation system for supervised learning and unsupervised learning. The recommendation system can be both classified into supervised and unsupervised learning, depends on what type of you are using. Suppose you are using classification, you can then go with the supervised learning, and if you want to do clustering, then you have to go with the unsupervised learning. I hope so. Yes, I cleared your doubt.